So 3.5 is just a review on graphing lines. And so we've been talking about graphing quadratic equations, and we know that they always form that U shape, that parabola. So what we're going to do in the next section in 3.6 is we're going to graph lines and parabolas and find out where they intersect. And so I want to just review really quick on how we can graph a line. There's a couple different ways and some important pieces of a linear equation that help us graph a line. So a couple of things. The general form is y is equal to mx plus b, where m is the slope and the y-intercept is the b part. And remember, the slope is the rise over run, so how much you go up over how much you go right or left. So there's two ways to graph. And so as we look at our first equation, we know a couple of things. We know the slope is 3 over 1. Remember, if there's not a number on the bottom, there's a 1. And our y-intercept is negative 2. We know that by two things. We know that because it's already in the form y equals mx plus b. But we also know that the y-intercept means what happens when the x is 0. So we would go y is equal to 3 times 0 minus 2. And so this goes away and we're left with negative 2. The same thing follows for the x-intercept as we solve for y. We put 0 in for y. And so we get 3x minus 2. And then we would add 2 to both sides. And so we get 2 is equal to 3x, divide both sides by 3 to get x is equal to 2/3. So the x-intercept is 2/3. Now that's a hard point to graph, and so we wouldn't normally graph that. Remember, for a line, because it goes on forever in both directions, that means your domain is negative infinity to infinity, or all real numbers, and your range is negative infinity to infinity, or all real numbers. So the easiest way to graph this, and this is how I usually graph, is I just graph these two. And I just do it a couple times. So I'm going to put a dot at negative 2 on the y-axis. And then my slope is 3, 1. So I'm going to go up 3, 1, 2, 3, and over 1. And I can do it again, 1, 2, 3, over 1. Or if I made them both negatives, I could go down 3, 1 to the left. And then all I'm going to do is connect those with a straight line. And then you'll notice, I know my dots aren't perfect, but you'll notice, let's see if I can do that a little bit better. Maybe. Go away. All right, so hopefully you notice as we look at this point especially, you'll notice as I make that line, see how it crosses at about 2/3. So again, it's probably not the best, but that works. All right, so even though we didn't graph that 2/3, notice that this dot right here is about 2/3 between 0 and 1. And so that's just nice to kind of help us know that we're doing it correctly. So as we do the next problem, the same idea. Notice that this time it has a negative in front of it. So your slope is negative 3 over 4. Your y-intercept is 5. And again, we know that because it's at the end, but we also could substitute 0 in. Our x-intercept is harder to find, so we're going to put y is equal to 0. It's negative 3/4 x plus 5. And so we would solve that like a normal problem. So we would subtract 5 from both sides. This would be negative 3/4 x. So we're going to multiply by the reciprocal. So we're going to multiply by negative 4/3. And so the x is all alone. And then over here we get 20 over 3. Because top times top, bottom times bottom. And 20/3, let's write that in green. So 20/3 is the same thing if I was to divide 3 goes into 26 times with 2 left over. Again, that's not an easy one to graph. Our domain is negative infinity to infinity, always. Range is negative infinity to infinity, always. So again, we're going to graph the slope and the y-intercept, and that's the easiest way to graph. And so we're going to go over here, we're going to put a dot at positive 5. And this time, our slope is negative 3/4. So that means we're going to go down 3, 4 to the right. Or we could have gone up 3, but that doesn't fit. So we can go down 3, 4 to the right. That doesn't fit either. So we only have 2 points on the graph that we can connect. And so we're going to connect them. And so this would be my equation. Now notice it didn't cross. Maybe we should do that again. Let me draw that line a little bit better for you. Maybe. Erase. Okay. Notice if I extend this line just a little bit more, I know that it doesn't, but if I was to extend that line just a little bit more, notice how it crosses at a little more than 6, like almost at 7, which is about 2/3 the way through. And so even though we don't graph that 6 2/3, my graph does cross at that point. So as we look at example 3, we get y is equal to 4. So what that means is y is always 4. We could rewrite this problem to look like y is equal to 0x plus 4, which means my slope is 0 and my y-intercept is 4. And if it's that, and I put in the x is 0, or the y is 0, so 0 is equal to 0x plus 4, there's no way for me to solve for x because x doesn't belong. X isn't there. So that means that there's not an x-intercept. And so now this one, domain and range, is a little bit different. So let's think about what it looks like as we graph it. So again, we're going to put a dot at our y-intercept at 4, and our slope means that we're not going up or over at all. Okay? I shouldn't say that. We're not going up at all because 0 is our top number. So really we could say this is 0 over 1, which means I'm going to go up 0 over 1. Or I could go up 0 over 1 to the other way. Okay, so it's going to be a horizontal line going through this point. And so notice how it never crosses the x-axis. That's why there's none. Domain, notice that your domain then would be negative infinity to infinity because your x's are going on forever. But your y's are not. Your y's are bounded, which means there's only one y value. And your y value is 4. Whoops. Why is that doing that? Okay. We're back. So our range then is 4. It's just going to be 4 to 4. Okay. It's always 4. And basically that's the way we're going to write that, is our y is always 4. All right, so those are the easiest case, and notice how they're always straightforward. And again, the things that we like to graph are the slope and the y-intercept. Sometimes our equation's in standard form, which means that it's not solved for y. We have ax plus by equals c, where a, b, and c are integers, and a is not negative. And to graph the standard form, you can solve it for y to get the y-intercept, or you can do the x-intercept and y-intercept and just connect those lines. And that's totally up to you. It depends on what your equation looks like and if it's easier to do one way than the other. So as I look at example 4, I don't have a slope that I can say right away. I also don't have a y-intercept or an x-intercept, but I could solve them. So if I'm solving for the y-intercept, I'm putting 0 in for x. So I would say 0 plus 4y equals 8. And so I would solve that by subtracting 8 from both sides. And then I would have, let me rephrase that. That's not how I would do that. If I don't have a 0 here, let's think about this. Look at what I'm doing. If I don't have a 0 there, then really all I'm doing is trying to get y all alone. So I'm just going to divide both sides by 4. And so I get y is equal to 2. So that's my y-intercept. If I go to find my x-intercept, then I'm going to have my y be 0. So I'm going to go x plus, let's do this in a different color. We're going to go x plus 4 times 0 equals 8. And again, 4 times 0 is gone. So we're left with just x is equal to 8. That's my x-intercept. So in this case, it would be easier for you to graph your y-intercept 2 and then your x-intercept 8 and connect the points. And if I do that, I can find the slope So if I connect these, well, that wasn't very good. If I connect them, let's go this way. Oh, whoops, that's not very good either. Pretend I didn't do that. All right, so if I connect them this way, there we go. I can figure out my slope by counting the rise over run just for those 2 points. So instead of me solving for y, which I will show you how to solve for y, but instead of solving for y, I could just count my slope. So to go from 1 point to the next, notice I went down 2, and then I went over 1, 2, 3, 4, 5, 6, 7, 8. So remember, it's the rise over the run. So this is -2 over 8, or -1/4. Okay, if I reduce it. And so I can count my slope as rise over run if I wanted to. And again, notice how your domain is -infinity to infinity because it goes on forever, and so is your range. Now, another way for us to graph this is by taking my equation and just solving for y. So notice, I'm going to do this over here to the side. So if I have x plus 4y equals 8, another option is I can just solve this for 4y. So I'm going to subtract x from both sides. So I get 4y is equal to -x plus 8. And then I'm going to divide both sides, or everything I should say, by 4. And so I get y is equal to -1/4 x, because there's really a 1 here. And then 8 divided by 4 is 2. So notice that I have a dot at 2, which I already had. And then if I went down 1 over 1, 2, 3, 4, down 1 over 1, 2, 3, 4, that I would still have that line. Or I could go up 1 over 1, 2, 3. Let's see. 1, 2, 3. Well, that one's off a little bit. Okay, but in general, that's the way I could graph. Okay. So down, up 1 over 4. That's off just a tad. All right, so example 5, same idea. If I have it x and y on the same side, then I don't necessarily have my slope right away, but I could solve for it. So, or I can just find my y-intercept and my x-intercept and see if they come out as nice, clean numbers. So if I'm solving for my y-intercept, then I'm putting 0 in for x, and I'm going to solve for y. So this goes away, and so I'm going to divide both sides by -2. So I get y is equal to -6. That's my y-intercept. If I'm solving for my x-intercept, I'm going to go 3x, and instead of solving for y, I'm putting 0 in for y, equals 12. And again, notice how that term goes away. So we divide both sides by 3, and so we get x is equal to 4. Again, both of those come out as nice numbers, so I can just put a dot at -6 on the y-axis and a dot at +4 on my x-axis, and then I'm just going to connect those lines. That's kind of off. I'm going to try one more time. That's not. This graph the grid's off just a tad. I don't like that. I think it's just elongated for some reason when it gets put on my thing. We're just going to pretend. That's pretty close. Okay. It should have gone through that line. Let's see if I can move it. Well, that's not doing what I want it to do. Anyway, that's my line. It's going to be close to that. I guess that's probably a little bit better. All right, so another way, so again, it goes -infinity to infinity for domain and -infinity to infinity for range. So it goes on forever. As you look at the slope then, I can count it, which would be the rise over run. So notice that I'm going up 1, 2, 3, 4, 5, 6. I'm going over 1, 2, 3, 4. So my slope would be 6 over 4 or 3 over 2. All right. So if I solve it, so if I take my equation over here to the side, one way to find the slope is just to count it, so rise over run. Another idea is I can take my equation and solve it for y. And so if I solve it for y, I would subtract 3x from both sides. I get negative 2y is equal to negative 3x plus 12. And then I would divide by negative 2. And so we get y is equal to a negative over a negative is a positive. And 12 divided by negative 2 is negative 6. So notice that my y-intercept is negative 6, which is the same as here. And my slope is 3/2, which is what we counted it as. And so as you look at, I could have gone up 1, 2, 3 over 2, and I still have a dot on that line. And then up 3, 1, 2, 3 over 2. There's my other dot. Okay. Down 3 over 2 is my dot, and it's still on the same line. So any of those would work. Another idea when we're looking for my equation to find my slope, we can graph our x-intercepts and count it, which is what I just did. They said you could solve. So again, I would say for example 6, same idea. We're going to have x be 0, and we're going to have y be 0 and solve. And so if we have x be 0, then we get 2y is equal to 10, because this goes away. We divide both sides by 2, so we get y is equal to 5, and we're going to just put a dot at positive 5. And then we're going to take same equation, but this time we're going to have the y be 0. So we're going to go 5x plus 2 times 0 equals 10. Again, this goes away. So we have 5x is equal to 10. We divide both sides by 5, so we get x is equal to 2. And so those are our 2 points. And then they're saying, well, you can find the slope by calculating the slope with those 2 points. So my points then are, we'll just do it over here to the side. My first point is the point 0.5. And then my second point is the point 20. And so if you remember at the top, they talked about how you can find the slope, that it's y minus y. So this is my x and this is my y. So if I do 5 minus 0, I get 5. And then I would do, so y minus y and then x minus x. And you just have to keep it in the same order. So then 5 minus 0 is 5, 0 minus 2 is negative 2. And so they're saying, oh, then I can find my slope is negative 5, 2. Which, notice, this is down 1, 2, 3, 4, 5 over 2. So we can find it the same way as if I just counted it. No, that wasn't really on there again. But that's kind of what they're saying. And you guys can kind of do what is easiest for you. But that's a quick review on graphing lines. And you're going to need that for 3.6. So hopefully that makes sense. If it doesn't, make sure you contact me and we can go over it before you get to the next section. So this is just a review. You don't have an assignment. I just want to make sure you know how to graph a line. All right. Thank you.